Okay, this is a very quick look at problem number 18 on page 124. How to graph this rational function, which is 1 over x squared minus x minus 6. Now, I've typed it in this way, but it's really smart to factor it first. So see if you can break that down into its two binomials that will multiply when you FOIL it to make that. Alright, so you can pause this and factor it. Maybe you can do it in your head. It's pretty standard. But if you're back, I hope you factored it, and it is x minus 3 times x plus 2. Now I could, with the double parentheses, type it in like that, and you'll see in a moment I do that. But right now I've got it typed in just as it appears in the book, and if I do zoom 6, that will take it to a standard window. Now there's some problem here, and whenever that happens, always press number 2 to go to what the error is. And what I've got is I've got this prompt that's showing you what page number it is, so I've got to go down there and delete that, and I just hit clear and it's all gone. Now when I go to graph it, it'll be fine. Alright, now this is what I call like the heartbeat pattern, and it's got some pretty serious problems. The calculator, when it gets to small numbers, will round it down to 0, and you see that it appears as though the graph does not go up into this region at all, or down into that region, or up here. But in fact, if you think about it in factored form, you do have the restriction on the domain that if it factors to x plus 2 and x minus 3, x can never really be negative 2 exactly or positive 3 exactly, because the graph will explode to infinity or negative infinity. So it is up there, but we can't see it. But to get a little bit better idea, just so I can prove my point, I'm going to go to zoom and then choose box. And I'll take and draw a box around it. And so you can see the cursor there starts at the origin, and so I'm just snaking up to a handy upper left corner, and that looks good. And then I'm going to open it. I press enter, and now I'm going to open it after thumbtacking it down, and it's a whole lot of arrows to the right until I'm past what looks like the interesting part, and then I go down as far as I think prudent, and it looks like that's about there. And now when I hit enter, it's going to zoom into that box and fit the screen. Well, you can see it's made it bigger, but I've still got these issues with it rounding off, and now the line is showing up where there had been nothing there at the top of my box, but still I've got problems. So this is where you need to use both your mathematical smarts and your calculator to draw a perfect, or at least a reasonable graph. But you can see that over on this upper left-hand side, it's basically that kind of a curve that hugs those two lines there, or asymptotes. And then it's an N shape here, an upside-down U, staying well below the x-axis and hugging the left asymptote at -2 and the right asymptote there at +3. And then on the other side of that, it's in the upper right corner. Okay, so by following along the suggestions in sample number, I think it is 2 in the book, and sample 3 rather on page 121, and then using your calculator, you can combine your skills to draw a reasonable graph. Now, just to show what it really looks like, since I can't sketch it on the screen here very easily, I'm going to show it on Geometer Sketchpad, which is this. I've typed in the function, and this time I did do it in factored form. And even Geometer Sketchpad has a little bit of round-off error here. This will continue to go upwards and upwards and upwards as it gets closer and closer to that line, that vertical line at -2. And it will go down here, hugging that asymptote as well as it does here. Now I can show the asymptotes with these red lines here. And the vertical one is right here. That's this one at x equals -2. And this is the other one at x equals +3, so I'm just going over to 3 on the x-axis and going vertically. And then this other one, this is the horizontal asymptote, and you have to ask yourself what happens to these values up here when x gets extremely large, positive, and extremely small, negative. And when x gets very, very large, positive, it becomes 1 over a really large number, which approaches 0. That's why this line comes down here and approaches 0 quite quickly and hugs it very, very closely. And then on the left-hand side, when it gets large negative, it also becomes 1 over a positive number, because a negative times a negative will be positive, so it comes down and hugs 0 from above like that. Okay, that's the idea, sketching those graphs. Thanks.